Thank you for the opportunity. This is a very pleasant um, for me to be able to speak here and to present about my research on global vulnerability mapping of coastal zones prone to saltwater intrusion, together with my supervisor, Holbert Odissings from Deltares and Yang Zhaozhu from IHE Delft. So, as we all know, that saltwater intrusion is in coastal zone is pressing global issues, and it has been impacting for a couple decades, and it getting worse, and it affects drinking water quality and crop production, and then it also enhanced by the fact that now the climate change has um, affecting our Earth, and also the population growth that are happening in most of the big city and also small cities all over the world. My research is to explore both intrinsic and extrinsic parameters that are affecting saltwater intrusion in coastal zones all over the world. And the primary of my objective is to create a vulnerability mapping and to identify the indicators uh, that have a significant influence on the vulnerability index of coastal zones to saltwater intrusion. And then the workflow of my research is that I'm collecting global data from open source, and then I'm formatting the data so that the data are in the same resolution, and then I assign weight and rate to the indicators that I found, and then I calculate the vulnerability index, and I did some validation and sensitivity tests, and then I do the analysis. And the data source that I use, maybe, yeah, you can see in the global data collection, I have 18 data sets, and I use 16 of them to calculate the vulnerability index, and then 2 of them as uh, validation. And I acquired this from open source data and also some archive from Deltares. And these indicators I group into 4 categories, which is climate, human effect, land surface condition, and aquifer properties. And then for 2 others are the groundwater salinity. Because there has almost none of methods that assign both intrinsic and extrinsic to calculate vulnerability to saltwater intrusion. So I manufacture my own formula based on the weight average models that calculates the weight and the rating all at once. Here you can see in the vulnerability index calculation, I use 2-tier calculation approach where I calculate per cluster first, and then I merge them into a global map vulnerability. And then the vulnerability results is that there are many of areas with high and extreme vulnerability, and most of them are in the big cities around the world, as you can see. And then the most influential indicators, uh, sorry, in the most concentrated region with high population rates and significant groundwater abstraction is the area that have high to extreme vulnerability. And then it consists up to 40% of coastal zones worldwide. And then the most influential indicators that are governing the vulnerability of coastal zones are aquifer type, distance from coastline, groundwater abstraction, and population density. And the results the indicators and the results that I have resulting, I did some 2 sensitivity tests. One is single parameter test where I use coefficient of variation to assess the impact of parameter weight. And the second one is the map removal test to identify the effect of excluding insignificant indicators from the calculation. Result from single parameter test shows that the land subsidence has the smallest variation, while the aquifer type and groundwater abstraction shows the highest variation. So when I change the weight, it most likely to change the vulnerability index result. And from the map removal test, it shows that different region exhibit a distinct reaction to indicator removal. So it emphasized that there is regional variations to this. And also, uh, as you can see in the small box, small table on the left, on the right here, it shows that the human impact has the highest effect on the vulnerability index. And the conclusion of my research is that, the map validation. So I validate my map with the electrical conductance data that I gathered from all over the world. It shows that there is a positive correlation between the EC and vulnerability index, which is confirming real world case that when my map shows a high vulnerability index, also in the real world has a high EC. The groundwater has high EC, which means that the groundwater is already saltwater in truth. And then the conclusion is there are approximately 40% of global coastal zones that that are now have high vulnerability to saltwater intrusion. And the key governing indicators that are really affecting the vulnerability is aquifer type, coastline distance, distance from coastline, groundwater abstraction, and population density. And the third one is the correlation between each cluster with vulnerability index shows that human impact has uh, the highest effect, followed by the aquifer properties. And yeah, thank you for your attention. And if you have any question, please, you can ask me. Or if you are interested more about this project, you can email me as well. Thank you.